Briggs & Stratton E-Tech motor. It's a permanent magnet DC motor, meaning it has mechanical commutation. The electricity is mechanically distributed by brushes, basically on a spinning armature. There's also a version of this motor which is what you call a brushless motor, but I personally wanted to go with the conventional brushed motor because I think that mechanical systems are going to be more reliable than electronic for me. And I would like to have the luxury, if I directly hook up the battery to the motor without any electronic intermediary speed controller, it'll spin. That way, if I ever do lose like my speed controller, that's the electronic controller for the motor, I could theoretically directly hook the battery to this motor and it would run. I wouldn't have, subtle control of the motor, but it would spin. And so for me, that's kind of like an added degree of safety and reliability. It weighs 22 pounds. It's capable of theoretically about 6 to 8 horsepower. Electric horsepower is kind of different than the ratings of an internal combustion engine horsepower. According to like the literature on electric boats, 6 horsepower electric you can figure will replace about 2 to 3 times that horsepower in like a gasoline engine, which I had before. So this should theoretically be a sufficient replacement for about an 18 horsepower inboard conventional inboard diesel or other gasoline internal combustion engine. It's very efficient. I'm going to be running it at 48 volts. And we'll see how it works. We'll see how it pushes my boat. In the original installation, the integral in the engine is like a thrust bearing, right? So since I took the engine out, there's no way to absorb the thrust. So what I need to build is a mount that has a special bearing. This is the bearing. And I got this on eBay for I got 3 of them for $21. But this bearing will absorb the load of the entire load that the propeller pushes. All right. So as the propeller's spinning, it's going to push the shaft forward, right? And if there were no thrust bearing there, essentially the propeller would grind up against the the hull. Yeah. So you need to set it up so that there's an appropriate bearing to absorb the thrust of the motor. So that's what we're working on tonight. Hey, Colin.
What's happening?
Colin's going to help me with my YouTube movie here about converting to electric power on the Pearson Vanguard. We're just, we got it set up, and we're just going to try and fire it up. We just kind of got it cobbled together with alligator clips. Here we go. So that should be forward. The chain is noisy. It's pretty noisy. I might think about going to belt drive in the future. It kind of roughly works out to torque is amperage. Amps give you torque, and voltage gives you RPM, roughly. Not exactly.
Interesting.
So, and the key is you want to get the right. Basically, you want to get the right prop. That's the most important thing, and then you want to set it up so that the voltage and the amperage matches that prop, and basically, so that prop can absorb as much of the power from the electric motor as possible. On this motor, the way we do it is it's geared, to different propellers. So that's one of the beauties of this, is that you can change your transmission ratio, right? The way that it's set up. All right. You know what is pretty amazing about this computer? It tells you what's wrong. It tells you where the loose connection is. It's kind of convoluted, but white stripe middle right.
controller, and we were originally getting about 60, 65 amps, and now we're getting boosts of about 130 amps, which, you know, we don't want to run it continuously that amperage, but it's good for getting in and out of the slip. Last time we had a bit of a hard time getting out of the slip, so here we go. We're just going to give it a shot. We're just going to start backing it up.
No fossil fuels.
Weird phenomenon to go into neutral and it's just dead silent.
Forward.
Thanks, guys.
Good work, good work. Nice landing.
Hey, you did it. Excellent.